So if you want to find the Taylor polynomial approximation of a function with two or more variables, you're going to basically do the same thing that you would for finding it with just one variable. The main difference you can see in the formulas is the derivative in front of each term. And the reason why the derivative is different is because for functions of one variable, the output is only changing with respect to x. But for a function of two variables, the function is changing with respect to x and y. So instead of just having f prime a, you have to have f prime a and f prime b because the function is changing with respect to two variables, and you need to find the partial derivatives of each of them. So you have to do this for every term. So for your second order term, you're going to have to find the second derivative with respect to x and your second derivative with respect to y. And you have to keep doing this with every term until you get to your nth term, where you have to take the nth derivative with respect to x and the nth derivative with respect to y. And that's so that your approximation is as close as it can be, because you don't want to try and approximate z if you're only considering how x or how y changes. To correctly approximate z, you need to take into account how both x and y are changing.